Well, thank you very much, and it's great to be here. I'm Dan. It's great to be here in person. It's nice to see so many people face to face, and I'm already enjoying the networking. So what I wanted to share with you today is a little bit of our journey, and in particular, I think something that's perhaps undervalued in the process of developing data science capability, and that's culture. But let me start first with something else, because I think what's really important when you start talking about culture is to focus initially on purpose. And for us at Shell, we recognize that the world faces an urgent challenge to try to tackle climate change in the midst of a growth in energy demand. And I think we have to recognize that climate change is real, and as a society, we have to act. And all of this requires an unprecedented level of change in our energy system, and we don't have all the answers. A recent IEA report indicated that nearly 50% of the reductions in CO2 will need to come from technology that's currently in the development phase. And it's a really tough challenge. To put in perspective the level of change that we have to achieve in the energy system, if we think about the recent COVID pandemic, and we look at the amount of CO2 reduction that occurred when we stopped flying and stopped driving, that was about a 6% reduction in global CO2 emissions. And so the level of change that we need to achieve in terms of our energy system dwarfs that level of change. And I believe that technology innovation is absolutely fundamental to make the massive changes that we're going to need to make if we want, as a society, to address the compelling challenge of energy transition. And so my talk today, I feel, is even more important, because it's all about how do we create a culture within an energy company like Shell that makes that sort of transformation possible. And today I want to try and share some of my experience, some of the things that's worked, and perhaps some of the things that haven't, in terms of generating a culture that's capable of adopting and scaling AI and computational science within Shell with the ambition of supporting energy transition. So I talked about purpose, so what about strategy? Well, we announced our new strategy earlier on this year. We called it Powering Progress, and it focuses on working with our customers to achieve net zero. And net zero means a world in which society stops adding to the total amount of CO2 and greenhouse gases that we put into the atmosphere. And we've been very clear in our aims. We want to achieve net zero by 2050 or sooner, in step with society. And we do believe, coming to something very positive, that data science, AI, and digital technology can make a really meaningful contribution towards that journey towards net zero. To give you some tangible examples, we're already using AI to reduce the footprint of our operations, to improve inventory demand planning, to reduce the wastage of raw products, and to decrease the time that we're using heavy machinery. We're also using AI with our customers to provide lower carbon solutions, to reduce renewables, to optimize the amount of renewables on the grid through smart charging, to reduce the fuel consumption of ships, and also to optimize the total performance of the grid using advanced battery storage. And we're also using AI and digital technology to design the next generation of energy systems. For example, we're using computational fluid dynamics and AI to redesign the way in which we install wind farms. We're also using AI and computational science to design new forms of hydrogen storage and electrical ethane crackers. And the impact of all of these use cases is already very material. For example, in a recent project in Nigeria, we were able to show through optimization that we can reduce the CO2 footprint of an LNG train by about 130 kilotons. To put that in perspective, that's the equivalent of about 57,000 European vehicles being removed from the road. Similarly, in the design phase, we're working with Dow Chemicals to design a new electrified ethane cracker. And we've seen already that we can use that, once implemented, to remove the equivalent of 350,000 European cars from the road. And some of the AI and IoT that we're already deploying to our mining customers is showing that we're able to reduce vehicle idle times in terms of heavy machinery by around 16%. I hope that gives you some enthusiasm for the potential that AI can have in the energy sector. And within Shell, what's exciting is we start to see digital technology and AI hitting scale across our organization. It was already mentioned in the introduction that the overall digital program within Shell is delivering about $2 billion of bottom line business impact in terms of margin increases, production increases, and also cost savings. But more importantly for me, we're seeing an exponential growth similar to that in the deployment of AI solutions across our business. We've got about 100 AI solutions being deployed at various stages of maturity across our business. And we've integrated vast quantities of time series data, around 1.7 trillion rows to date, in an integrated data lake that allows us to gain real-time performance insight into our assets. We've got over 7,500 pieces of equipment being monitored live by machine learning models in order to detect issues and improve reliability. We've also seen a 10x increase in the use of virtual rooms during the COVID pandemic, which is around offshore facilities and refineries and LNG trains, but also areas like wind farms and solar parks, starting to use these virtual rooms to provide real-time, over-the-shoulder coaching to engineers in the field. We've got around 1.7 million users of our AI-powered loyalty scheme, Go Plus, in the UK. And we've also got around 350 data scientists and computational scientists who are working in Shell on developing these solutions. And perhaps most importantly, and something I'll return to later, we've engaged over 5,000 individuals through our AI network. So an impressive set of numbers, but to give you an idea of the growth, just a couple of years ago, you'd have been talking about a few tens of machine learning models, a few 100,000 rows in a data lake, and also a few drone inspections and robots operating in the field. And hopefully that gives you an idea of the exponential growth that we're seeing and also the impact that it's having. But the challenge in all of this is scale. And it links back to my initial premise that we need to act more quickly than perhaps we've ever acted before to transform our energy system. But we also need to do it at scale to solve the sorts of problems that we have within the energy sector. And so to make a meaningful contribution through AI and digital technology, it's all about scale. And scale is not easy. We have to balance both agility and also autonomy with also the replicability and standardization. Because to develop an initial proof of concept locally is actually relatively expensive, and it also doesn't have the sorts of impact that I'm describing. But that's where the ideas originate from. At the same time, if we want to have impact at scale, it's about replication and being able to impact large areas of our business with a common solution and a consistent digital platform. And so for us, we've been learning about how to balance that. And what we've been trying to do is, on the one hand, allow local users to experiment quickly and to solve problems that they have within their specific business units, but also to have standardized methodologies, consistent platforms, and common data architectures with clear digital roadmaps that provide business prioritization to the sorts of solutions that we're developing that allow us to ensure that solutions that solve a problem in one location in our business are scaled and replicated globally. So it's that standardization that's really important, and the value and the impact comes from the scale-up and replication. But that's only half the picture, because as I said, the best ideas come from the people who are closest to the problem. And so what we've tried to do is marry up our central initiatives with the ability for people in the field to move quickly and to test and learn and iterate and identify the best solutions to the problems. And so we've spent a lot of time providing education to our frontline staff around what these technologies can do. We've also developed a DIY platform because within our organization we have many scientists, chemists, physicists, geologists who have deep technical skill sets who are capable of understanding and developing simple machine learning models to solve everyday problems. And so we've been empowering them with training, with support, and also with a common platform, which we call the DIY platform, which allows them to develop these solutions easily and quickly and test the impact in the field before we head into a global scale-up and replication program. To give you an idea of the sort of impact this DIY program is having, let me give you another example. A chemical engineer in Moerdijk recently built an application to optimize furnaces by reducing their energy consumption and greenhouse gas emissions. And that local solution is now being implemented within the site, but we've seen the global potential and the opportunity to impact many more furnaces globally as we roll this out. But once again, it's not all about this overall cultural shift within the organization. It's also about trying to create organic communities that can drive the change. Because the other thing that I've learned along the journey is that often these central programs with executive sponsorship help, but actually it's the community of practice and the bottom-up movement that really changes the culture. And so we've focused very hard on building these communities of practice within our organization that can actually start to drive the change and make an impact to the adoption. The Shell.ai community started in the earliest stage. It started around 2013, but it's grown dramatically over that period. It started with about 30 members. It's now over 5,000. The Shell.diy community has had a similar exponential growth rate, and we now have over 1,200 DIY solutions that have been developed across our organization. And to give you an idea, when we bring these two communities together through our annual awards that we run each year, we now have about 571 different projects and programs entering for these awards for recognition for what they've done and the impact that it's had across our organization. And to further that development, around the awards, we organize hackathons and boot camps to help these DIY data scientists and DIY software developers to hone their skills and to further understand what the technology can do within their business. And many of them are now going through formalized training. We're offering Udacity nano degrees to these people to help them to have these formal skill sets in order to further their career development, and in some cases even to become professional data scientists. But I've talked a lot about the internal picture. Of course, we recognize that we can't do it on our own. Within Shell, we need partnerships. I talked about the Powering Progress strategy and the fact that we need to work with our customers, but we need to build ecosystems that can help us to accelerate digital transformation. For example, we've been developing major technology partnerships which are designed to help to accelerate the energy transition. And perhaps the most prominent example has been our partnership with Microsoft. We're leveraging the Azure Cloud Platform to help us to roll out solutions like Azure Machine Learning in order to accelerate the DIY journey that I talked about. But at the same time, we're also providing Microsoft with green electrons, to date around over 300 megawatts of renewable power to power their data centers. And so it's that joint partnership, the acceleration of energy transition through customers, but also leveraging the capabilities that they bring to the table that we see as so important. But it's also about ecosystems, not just partnerships. Breaking down walls across supply chains, if you will, digital supply chains, to create integrated platform technologies that accelerate the sort of change that I'm talking about. And if we want to accelerate change, siloed approaches to digital platform development is never going to work. And so what we've been doing to try and transform the development of our assets is work in open ecosystems with shared common data definitions and open APIs to allow common platforms to be deployed into our assets to accelerate the change. And an example of this is the Open AI Energy Initiative, where we're working with Microsoft, C3, and Baker Hughes to figure out ways in which we can develop interoperable solutions for things like optimization and reliability. And this has a number of benefits. It allows us to work together to create common digital solutions, but it also allows us to open up to startups who are looking for robust, stable, deployed digital platforms on which they can scale their offerings. And of course, this also helps Shell by accelerating the pace of digital development within Shell by making it easier to adopt solutions from the outside. And perhaps most important of all is open source, which we see as a cornerstone of any strategy to deliver digital technology in support of energy transition. For example, for many years, we've been supporting the development of an open source framework called GWSStat, which is all around the monitoring and evaluation of groundwater conditions. We're also more recently supporting the development of SK Time, which is a leading independent AI software toolbox for time series forecasting. And of course, we're supporting the development of open data standards, in particular the OSDU, which Shell led the development of, which is trying to create common standards in terms of the underlying data platforms for the energy sector. So in closing, the world faces a big challenge, and that's energy transition. And energy transition is a very hard problem to crack. And I believe, and we believe, that AI and digital technology has a major role to play. But to deliver the impact, it has to be at scale. And to do that, we have to create a culture which can accelerate digital innovation to achieve the sort of transformation that the world has never seen. We're very excited by our progress. We believe we're heading in the right direction, but we also recognize there is so much more to do. Thank you. I'm happy to take any questions if there are any. It's a great question. So how hard is it to drive cultural transformation in an organization like Shell? I think, look, like any large organization, and certainly one that's been around for a long time, we have embedded ways of doing things, and that takes time to change, and often for very good reason. I think also the other thing that's really fascinating about it is that it takes really strong leadership, because it really takes leaders that want to make the change and support the change and drive the change and enable the frontline staff to open up and to think differently about what they do every day. And I think that's been, for me, what I've been fortunate with, that I've had that sort of leadership. But it's not easy, and you also see that there are people that are open to the changes and those that are not. And my experience has been, you work with where the energy is. And I think that also creates the example, and gradually you build the momentum over time. And it does take time. I think the other thing that's really helpful for us is the external environment tells us we've got to change quicker. And I think that also, that external compelling reason to act helps us to accelerate the change internally. So it's not easy. We've had our moments in the journey where there's been some frustration, but I think what's exciting is that I see the momentum shift across the organization now. Not amazingly, there's a mic just coming.
I'm just going, here we go.
Thank you. Can you hear me now?
Yes, go.
So from a upskilling and reskilling perspective for digital skills of your current workforce, should we say office workforce, you mentioned Udacity and the nano degrees. I'm really interested about that because it's quite difficult to reskill and upskill people to modern tools and culture change as well, and it'd be great to hear a little bit more about that.
Yeah,
Thank
for sure.
You.
So let me start by saying, in terms of upskilling and reskilling, we started from a premise, and the premise was, actually it's very hard for us to hire the sorts of skill sets that we need. And the reason for that is that a lot of them are what we call hybrid skill sets. So we need people that understand renewable power and machine learning. And those things aren't easy to find. I think the great thing we've had is that within our organization, particularly in, if you like, the younger generations, if I can put it that way, so those coming out of university now, the graduates and those who are a few years into their careers, there is both a background and an energy around this and an openness to it. And so we've gone, not exclusively, but we've focused heavily on trying to focus on those people that have that kind of interest in and have the right background and those right hybrid skill sets where they could be upskilled and reskilled. I think also what's been really interesting is we also recognize that if you look at some of the technologies from the previous generation of the energy industry, so things like subsurface modeling, which is obviously still going to be very, very important for some time to come, but perhaps there are some people who may want to move out of that because different skill sets are required for energy transition. Those people have phenomenal backgrounds for machine vision because they've been doing image processing. And so there are many of these areas in Shell where you can look at how you can transform existing skills with the right sort of background and good understanding of the energy industry. But we've had to make it a systematic program. So we worked really hard with our learning organization to develop a common, first of all, discipline. So basically we put data science and computational science on the same level as chemistry and physics within Shell, and geology and the other things that we do. We've also worked really hard to make it systematic. So within my department, for example, people can take up to a day a week to do a nano degree. So we've put aside dedicated time to allow people to upskill themselves in these areas. And the final thing is we focused really hard on the leadership culture to support people doing this, because actually without that it doesn't work. So, I mean, I could talk for a long time about this topic, but those are just some of the things that we put in place. And it's not just the nano degree program, there's also other training at lower ends that we brought in as well.
Any other question?
Hiya. So a question about, you were talking about like breaking down business unit barriers and enabling platforms. Kind of what came first in that journey? Was it starting with like enabling the data to be there, or was it building out the platforms? And how did you approach that problem?
Yeah, it's a really interesting question. We thought long and hard about that. I think what we wanted to do initially was we wanted to focus on the problems. So a lot of what we did was we did just enough platform development to solve the problems. That was intentional. It meant that we didn't try and solve all the data problems, and we didn't try and build a full all-singing, all-dancing machine learning platform on day one. We built what was needed to solve the problems that the business wanted us to solve, and we built out from there. Now we have a fully integrated Shell.ai platform with a fully integrated data lake, and it looks very nice and pretty, and everything's kind of there. But we didn't set out to build a platform. We built the platform along the way. Now, it's interesting. I'm not sure if I'd do it that way again. I'm just sharing some of my own the things that I kind of wish probably that I'd spent a bit more time on the platform early on. It's a delicate balance, because if you do too much of that, you spend a lot of money because platforms cost a lot, as you know. And then you also end up not delivering the value because you're too focused on the platform. And so it's a really delicate balance. But I think I wish that we were, in a way, had more of the foundational technologies in place earlier, because it would have enabled us to go faster now. And we spent a lot of the last couple of years kind of fixing some of the platform issues, which were sort of legacy issues from what we were doing previously. So yeah, it's really hard. But what I would say to anyone starting is, please focus on the use cases, because at the end of the day, if you're not delivering the value for the business, you're never going to get the sort of investment you need to be able to build these platforms.
All right, fantastic. Thank you, Dan. Thank you.
Thank you for having me.